this is Tucker from the Math and Physics Resource Center at SVSU. In this video we're going to go over another hypothesis testing example. So with this example we have a local politician claims that their rival has an approval rating of less than 45%. A random sample of voters taken by an independent third party showed that 109 out of 225 respondents supported the rival. Does the study provide evidence to support the politician's claim? Use a significance level of 0.05. So a significance level being just alpha, so our alpha for this one is 0.05. Okay, so just like the last problem, the first step in this is to figure out what kind of test we're going to be doing. So since we're dealing with a percentage and a sample that has a proportion in it, because it's 109 out of 225, this is going to be a 1 proportion z-test. Alright, so now let's just pull out all the information that we need. So if the original claim is dealing with this 45%, then we're going to say that our p, the population proportion, will be 0.45. Since we're going to be comparing to this baseline of 0.45, we can assume that this is the original population proportion that we're dealing with. Now, it says that a random sample of voters, blah blah blah, 109 out of 225. So 225 in this case is our n, because that's the sample size. And our p hat will come from 109 divided by 225, which is 225, 0.4844. Alright. So now we need the standard deviation, which we can get from the square root of p times q all over n. With this problem, our q we can get from the p up here, so 1 minus the p is q, so our q in this case is 0.55. So our standard deviation will be the square root of 0.45 times 0.55 all over our n, which is 225. And I worked that out to be 0.033166. When you get a decimal that goes out to a ton of decimal places, you'll want to try to keep it as unrounded as possible while you're going through the problem, just to make sure that you don't end up with some little error midway through the problem that messes up everything. Alright. And finally our alpha, which we figured out to be 0.05. Okay, so now we've got all the stuff pulled out, and now we can move on to the conditions and see if they pass those. So first, the sample is randomly selected. It says in the question that it's a random sample of voters, so that passes. And the sample is sufficiently large. Remember, to get that, we take n times p and compare it to 10. If it's equal to or greater than 10, then we pass. So our n, 225, times 0.45, that's about 100, a little over 100, which is well over 10. So we're going to pass that too. Alright, so now we can actually move into the math part. So remember, we're going to find the z value. Well, actually, no, I'm sorry. We need to find our hypotheses first. We need our null hypothesis and our claim hypothesis. So remember, since we're dealing with this 0.45 as our comparison, our null hypothesis will be that our p is equal to 0.45. And then we're testing to see if their approval rating is less than that 0.45. So we'll say that our claim is that p is less than 0.45. Okay. So now, let's move into the actual math, like I said earlier, where we're going to find our z value. So, remember, we're going to take our p hat, subtract p, all over the standard deviation, which with our numbers, that gets us 0.45 minus, or I'm sorry, I mixed those up, 0.4844 minus 0.45 all over the standard deviation of 0.033166. which gets it to z about 1.04. Alright, so now that we have the z value, remember we have two different ways of solving this problem now. We can either do the p-value method or the z method. The first one I'm going to do is the p-value, since we were given our alpha at the beginning here as 0.05. Alpha is 0.05. We're looking for a p-value of less than that in order to reject. So let's find the p-value that corresponds with our z here. We've got 1.04, so let's go to 1.0 and then all the way over to 4, and this is our p-value. Remember, since we're dealing with a claim that's less than 0.45, our area of rejection is going to be on the left side too. So we don't actually have to edit this number that we get from the table at all, because that gives us the area to the left of our z. So in order to reject this one, we would need a far more negative z value. So since our p-value is that 0.85083, which is way bigger than 0.05, we're going to fail to reject the null. Now let's do the z-value method, which is kind of just working backwards from the p-value. So we would want to find the p or the z that corresponds with our alpha here, which, since I only have the positive z-value table, we can't find that right now. But the z alpha that corresponds with that is negative 1.645. So remember, since we're dealing with the left side, in order to reject, our z has to be less than the z critical. So let's plug in what we have. The z critical is negative 1.645, and our z is 1.04. Now, since 1.04 is way bigger than negative 1.645, once again, we fail to reject. I'm not going to write all that out. It's not worth it. Alright. And then, remember, now that we have the outcome, we want to write a little statement that's in the context of the problem. So we'll say that there is not sufficient evidence, I can't type, to support the politician's claim. We can't say that the approval rating is below 45%. Alright. So once you get to that statement at the end, that's pretty much it. Remember, with these two different methods, you'll just want to make sure that you're paying attention to which side you have to actually reject on, and that's based on the claim hypothesis that we had at the beginning. So if we're looking for a less than, we're dealing with the left-hand side, and if we're dealing with greater than, it'll be on the right side. And that's about it. Thank you for watching.